Hello viewer, welcome to Samuel Academy. In this video, I am going to discuss about section 2 of waves as taught in form 3. Now, before us, we have that diagram which shows the general appearance of a wave. A wave has several parts or components, and I'm going to discuss or explain what they mean. We have what we call the wavelength of a wave. The wavelength of a wave is the distance between consecutive troughs or crests. For example, in this diagram, these are crests which are consecutive, and this distance from here to here is the wavelength of the wave. That's the length of a full cycle. Even from here to here, this one cycle, and so the distance from this point to this corresponding point is the wavelength of that wave. Now, frequency. Frequency is the number of waves passing a point per second. It is measured in hertz, H-E-R-T-Z, or just Hz. So frequency is the number of waves passing a point per second, or the number of cycles per second. And then we have the wave speed, or the speed of the wave, which is related to frequency and wavelength. The speed of a wave is the speed at which energy is transferred, right? And the relationship between velocity, or rather speed, wavelength, and frequency is such that speed v is equal to frequency times wavelength. Now let's look at some other important component of a wave. That is the amplitude. The amplitude from here to here, or from here to here, that's the amplitude A, is the maximum displacement from the equilibrium position of a wave. So this being the equilibrium position, the wave oscillates or vibrates like that, and the maximum displacement is the amplitude A. Okay. Now we have mechanical waves such as water waves. These waves require a material medium for propagation, or rather, they require a material medium to travel. But electromagnetic waves such as light waves, radio waves, or ultraviolet waves do not require a material medium in order to travel, right? Like light can travel through a vacuum. The light from the sun reaches us just by radiation, and it travels through a vacuum from the sun to the earth, where we have space. Light is able to travel because it doesn't require a material medium. Okay, all electromagnetic waves are transverse waves, and they travel at the speed of light, which is 3.0 times 10 raised to power 8 meters per second. Now, what do you know about transverse waves? Transverse waves vibrate or oscillate at right angles to the direction of their propagation, or rather, the direction of vibration of transverse waves is at right angles to the direction of travel of the waves. Contrary to longitudinal waves, such as sound waves, they vibrate in the same direction as the direction of travel. So let's look at something else which is about a reflection of waves. Before that, let's look at the relationship between frequency and wavelength. In this diagram, we have two waves, two forms of waves, this one and this one. All right. The first diagram shows that within the same time, in 10 seconds, from here to here it is 10 seconds, or the distance is 150 centimeters, we find that this wave makes more cycles per second than this one here. So this wave has higher frequency than this one here. And because the speed is the same, is constant, we find that the wavelength reduces, because we know that the velocity of a wave is equal to frequency times wavelength. But if frequency is high, it means that wavelength is going to be smaller. So in this case, this wave has a smaller wavelength than this one here, because this wave makes fewer cycles per second. It has low frequency. We can see the waves are 1, 2, 3. It makes 3 cycles in the same period of time. And this one makes 1, 2, 3, 4, 5. 5 cycles in the same period of time. So the first wave has a higher frequency than the second one. And then we see that the wavelength here is smaller than here. Here it is bigger. So this is the relationship. When frequency is high, it means that the wavelength will be shorter for a given value of velocity. When the frequency is low, it implies that the wavelength will be longer for a given velocity of the wave. Like if we consider electromagnetic waves, we find that waves like ultraviolet waves, X-rays, they are high frequency waves, and so the wavelength is smaller. But waves like radio waves, they have low frequency, and therefore they have very long wavelength. So that's the relationship. Next, let's look at the reflection of waves. Now, we want to consider reflection of this type of waves from a source being reflected from a plane reflector. This is the plane reflector, and these are the incident waves onto this reflector from this source. So this is the result. The waves are reflected from that plane reflector like that. Okay, so that's how it happens. Next we have reflection of circular waves, circular water waves from a plane reflector placed at an angle to the path of the waves. So these are the circular water waves. There are 3 waves, 1, 2, 3, and they are incident on this plane reflector, which is placed at 45 degrees to the horizontal. So this is what will happen when the waves hit this plane reflector at 45 degrees. This is how they are reflected from that plane surface, and the loss of reflection, they are held, they stand. Okay, that is the angle of incidence is equal to the angle of reflection at the point of incidence. This is the normal. So this is the reflection that will happen when these waves hit this plane reflector at that angle. Next, let's look at reflection of straight waves on a concave reflector. So these are straight waves which are incident on a concave reflector. This is the concave reflector, So this is what happens. The blue lines, the blue curves, they show the reflected waves, right, from the concave reflector. They take the shape of the concave reflector. You can see they are concentric with the concave reflector. So that's what happens, and they tend to converge towards the principal focal point P. All right. Next, we found that that's the end of the video. So I hope you have enjoyed viewing the video. You can subscribe to my channel to be able to see more videos in physics and other sciences and so on. Thank you so much and welcome.